Hello and welcome to episode 28 of TGI Kubernetes. It is Friday, March 2nd. We're at the start of a new month. And so here we go. Really looking forward to this episode. We have Neuro T1 Cal saying hi. And Tim from Bristol. Good to see y'all. So I'm really excited about this episode. Well, first of all, so my name's Joe Bita. I'm a CTO and founder of this company called Heptio. We're helping to bring Kubernetes and cloud-native thinking to more companies and more enterprises and just more people in general. And TGI Kubernetes is a chance every week, every Friday, where I play with some technology, explore some aspect of Kubernetes. I do it live. There's people in the chat over here, and it's scrolling away on me there that join me, ask questions. And so I really like to make it as interactive as we can with the time delay that we see with the chat with YouTube. So So first of all, so Lamati, good to see you again. We have Bismarck and Jay Hernandez and Parthaban from Atlanta, Alex Silviu from Basel, Hans saying he liked last week's episode. Okay, that's great because I have a blog post I'm going to talk about. Alex, good to see you. Julian in New York. Seattle weather. I was down in San Francisco yesterday and it was raining. It was hilarious. All the San Francisco people can't handle rain. David, Kevin from Toronto, Carlos, hola, Eddie from Guatemala, Saeed in London, Walid in Saudi Arabia. Saudi? Is it Saudi Arabia is the correct? Or do people just say Saudi? I have no idea. You can tell. I'm clueless. But thanks for joining us. We have Christian from West Orange, New Jersey, Aaron and Alpesh. Steve, Bob, let's see, and then Mahipal from Sweden/India. I'm not sure how that works. You got to be in one of those right now. Or maybe you're in the air. I don't know. I mean, you could be flying from Sweden to India. Walid, Kyle, Mike, good to see y'all. Stefan. All right, so I'm going to stop because this is, but thank you all for joining me. I really appreciate it. And I know that Heptio was at Container World this week. We had a booth, and I know there were a bunch of folks from Nutanix, Samir and his crew, that stopped by the booth. I wasn't there, but they told Sarah, who was there, that they get together in a conference room and watch every time. So, if you're watching this one, welcome. If not, hopefully you can catch it on the when we have the video. So, yeah. So, Gabriel says the entire gang is here. Patrick from Marseille, France. Wow, that's awesome. Awesome. So, thank you for joining me. I'm really excited about this episode. So this week we're going to be covering StatefulSets and CockroachDB and talking about some of the approaches to running stateful workloads on top of Kubernetes, what works, what doesn't work, and hopefully give a little bit of context there, and then play with Cockroach because it's really an interesting system, and the person who's doing all of the sort of Kubernetes work for CockroachDB. I used to work with him when he was at Google. So so really looking forward to that. But let me switch to my screen, and I want to do a little bit of sort of what's going on in the Kubernetes sphere. So the first thing, last week, I teased this blog post that Dave Cheney was going to be writing about how to deploy web applications with Kubernetes and Countour and LetsEncrypt and Jetstack Cert Manager. That would have been a long title. I'm sorry we didn't put that in the title there. But this goes into a lot of detail about how to use all these things together, and including Cert Manager. And Cert Manager is sort of the successor to KubeLego. And it's much more flexible in terms of mapping which certs you want, which authorities you want, and how it actually sort of interacts and proves those things. So really interesting. It works with any sort of certificate authorities that you might be running on premise also. So really interesting stuff there. And so Dave wrote all this, and so this goes a lot of detail here. And along the way, we found some issues and smoothed some things out, so a lot of good progress there. Thanks for writing that, Dave. And then I took the last episode where we talked about securing the dashboard and using the and using the OAuth proxy and all that stuff. And I turned that into a blog post also. And so just so to be more of a reference, I found some of my own details that I chased down in there, some bugs and stuff. So that was really good. One of the things, though, if you go down in the comments, if you show responses, Joe here was saying that there's a bunch of forks out there of the OAuth 2 proxy, and sort of the bit.ly code is not super maintained right now. And so really interested to see, if anybody has any details on those, that, maybe, there's sort of a sort of winning successor actually showing up out of that stuff. And then Lucas here brought up a really good point. And so I drew this diagram here, if you watched last week, where'd it go? Here, about sort of which links were HTTPS and which ones weren't. And I think the critical thing here is that this link here is, between the OAuth 2 proxy and the Kubernetes dashboard, is not encrypted or authenticated. So one of the things, and I should probably do this and maybe change the blog post, is we changed the network policy between the OAuth 2 proxy and the Kubernetes dashboard. In the Heptio Quick Start, we had a network policy that locked down the dashboard. I removed that, and I did the same thing in this blog post. We should probably make that more specific to really lock that path down. So that's something that's interesting, an interesting note there. So let's see. So we have John from Wyoming, Ibrahim, good to see you also. Ralph, down in rainy San Francisco, I assume. I don't know where Ralph is these days. With a drink in his hand is where Ralph is. It's past 1. Let's see. Chris and Shad from Cincinnati, good to see y'all. Yeah, all right. So let's see. So other stuff that's going on. Tom from New Zealand, how's it going? You're living in the future. It's already Saturday morning there, right? And Brad from Madison. All right, so the next thing, this is really interesting also, is Kubernetes moving to graduate to a full project of the CNCF. So the Cloud Native Computing Foundation actually have different classes of the different classes of projects. And so there's graduated projects, there's incubating projects, and then there were these things called inception projects, but they're reworking that, and there's going to be like sandbox projects. And it turns out that technically Kubernetes, even though it was a founding project, was a incubating project in the CNCF. Well, we've gotten enough act together that we can meet all the criteria, and we have governance and all that stuff, that we finally are moving towards making Kubernetes a full project of the CNCF. It's kind of a little bit of a ceremony type of thing, but it's kind of exciting to see that happen also. So Ralph says it's rainy in San Francisco, but it's not 5 yet, so he doesn't have a drink in his hand. All right. So Jason, good to see you. And then Jacob in Fremont. Is that Fremont, Seattle, or is that Fremont, California? I'm not sure which Fremont it is. I'm sure there's other Fremonts too. It's a neighborhood in Seattle, Fremont, for those not familiar, and it's actually where the Google offices are in Seattle. All right, so quick digression. So I was in San Francisco yesterday, and it was raining, and like everybody in San Francisco like freaks out because, oh my God, rain. And so they walk around, and I was wearing a coat. It wasn't even a raincoat, but it wasn't raining enough to get me wet. But everybody has their umbrellas out, and they're like poking you in the eye and stuff as you're walking down the street. But the biggest thing that shows that they're total noobs to the rain is you're walking and you get to a stoplight, and like anybody who like lives anywhere where there's rain, you take like a couple steps back from the curb, because if you're not careful, some car will drive by and give you a big old splash. But everybody in San Francisco is like right up on the curb, ready for the walk light. I thought that was kind of funny. They're total noobs when it comes to rain. Okay, Matthias from Berlin, good to see you. Yeah, umbrella warfare, exactly. All right, so other interesting stuff that I saw, and again, I put all these links in the show notes, is Ahmet, who's, I believe, at Google. So he's a Googler, wrote up a blog post that covers another Google engineer. This is Tim Altclair's, wrote this sort of like crazy script for essentially doing debugging of a Scratch container. Because what we find is that a lot of folks create these sort of super bare minimum containers that are optimized for running. But if you have to like get into those things or start debugging or start poking around, you find that like oftentimes you don't even have a shell to be able to to sort of shell into the process. So like kube control exec works only if you have enough support already in that container. And so what this is it's a write-up of the script that Tim wrote, which there's some crazy stuff going on here, but essentially goes through and starts up another container that's privileged that then uses Docker to sort of reach around and start interacting with the container directly to be able to copy in and set up BusyBox inside of the thing. That's really interesting. And I think, but this is to get you working right now, but there's also been a lot of talk of this feature called debug containers, which is this idea of launching new containers to be able to do debug type of stuff. So, so this is a really great tip if you're going to be figuring out how to debug containers that are from scratch or sort of super minimal containers. So let's see. So we have DS Lawyer in sunny La Jolla. Mateus from Berlin. Yeah. Pros when it comes to rain. Yeah. You guys don't have any hills, though. Berlin's super flat. It changes things. And then Lametti says, do you happen to know if the Kubernetes debug container project will make 110? Well, 110 is in code freeze now, so I don't think that's the case. Let's see, is this? Just clicking through here. I don't see. Yeah, it says okay. So verb here. Who's this? I don't even know. This is at Google. Leave or burn. Apparently, has been working on this. Says we made significant progress, but could not agree on the API in time for 110. This slips to 111. And this is actually somewhat fascinating. Is that, and it's something that you see a lot of times that happen in open source projects as they mature. Is that people get much more careful, much more deliberate, and so you don't see features necessarily make their way out as fast as you might like. And I think this is a great example. But what you mean is that. What you see is that people really take their time to make sure that they get the APIs and the interfaces right. And so it leads to a certain amount of stability over time, because I can tell you that in a commercial setting, when you're more feature driven, you just get this thing in there, you pick an API, maybe you don't consider all the angles, all the ins and outs. And so it's kind of the price you pay for a long-term sustainable project is that as it gets older, you don't necessarily see the feature cadence that you might like because people are trying to be more careful. So yeah, so that looks like it did not make it for 110. All right, and then we have Neuro T1 Cal saying dreary Woodinville. Yeah, so it's pretty dreary. Actually, it was really nice earlier. The blinds are down, I can't see it, but we totally saw the mountain earlier. I think Chris posted a picture on Twitter. Yeah, all right, so let's see. So what I want to cover is, so let's start jumping into sort of stateful workloads on top of Kubernetes. And I know Chris is writing something on this. I'm not quite sure how it's going to make its way out, but I want to get crisp about what we talk about when we say a stateful workload. Because this, I'll confess, this actually confused me a little bit. Because when you think about like from a sort of computer science-y point of view, state is anything that's like a state machine, right? It's like it's state is a sort of principal part of sort of a von Neumann architecture, right? Of a Turing machine is this idea of state and position and all that. And so you really don't have any program out there that doesn't have any state. And if you really talk about a stateful program, what you mean though is that it doesn't store any data, right? So if you want to be super duper pedantic about this stuff, right? If you want to be really, really pedantic, every program is essentially stateful. What people mean when they say stateful workloads, at least with respect to containers, with respect to this stuff, is long-term state. Things that are being stored on disk, really, and it's stuff that's directly managed. And so I think instead of stateful, like a better term might be like, I don't know, workloads with disk with files. I don't know, right? That's actually, I think, more accurate in terms of this stuff. And sometimes people talk about stateful applications, and I don't think that makes a ton of sense either, because a lot of times, especially with microservices, but even with more traditional multi-tier applications, what you tend to do is you tend to concentrate a lot of your state into like a database. And you'll see this pattern with Kubernetes itself, but this is super duper common, is that the workloads that are running are relatively stateless, but all the long-term state gets stored in a database. There's kind of an in-between there, and I think this is something that's interesting, is that, and you'll see this with more legacy applications where you'll have a web session, right? So like you'll connect to a browser, that browser will actually return you a cookie, and then every time you connect, it'll actually use that cookie as a key into a map, right? And more modern architectures, that map gets stored into a database, which means that your front ends are truly stateless. It doesn't matter which front end you hit. It can actually read the state for your session out of the database when you're doing session state-based type of stuff. But a lot of legacy applications, they weren't built to scale out. And they didn't assume that they would ever be restarted, because why would you do that? And so then they actually end up storing that state in memory, right? And so that's a type of stateful application that I don't think anybody has really talked about handling well with something like Kubernetes. And so when you start having people talk about things like session stickiness, it's that, hey, when a request comes in, you want to route it to the right back end so that you can actually maintain that level of in-memory state, that in-memory session stuff. So what we mean here in Kubernetes, in the container world with stateful workloads, means workloads that access a disk, that have files. And I say workloads instead of applications, again, because it's usually part of an application. It's your database. Or it's an external service, right? So if I have something that talks and stores and manages files in S3, that I wouldn't consider that to be a stateful application, because you can shut it down and start it up, and like everything can rehook itself up and everything sort of recovers, right? Whereas if you totally eliminate everything with your database and try and bring the database back up, obviously it's not going to be where you wanted it to be. All right, so once you start dealing with this idea of disks and volumes and stuff like that, what you find is that a lot of the primitives that we built with Kubernetes, things like deployments and replica sets, really aren't built to deal with this stuff very well. Specifically, if you look at persistent volumes, the most common way that we see these things working is that they are accessed over the network, and only one virtual machine, or one machine, even if you're iSCSI, only one machine typically will talk to that block device at a time. And so you'll see this when you, in the YAMLs, that you'll have this access modes and you'll have read write once, right? And that's essentially saying, hey, this means that only one thing can be reading and writing to this thing at a time. And there's these really esoteric topologies where you can have iSCSI with multiple people talking to it at the same time. It takes a very sophisticated and special purpose type of workload to access that. Most of the time what happens is that the file system driver that's running in your kernel that's talking to the block device assumes that it's the sole writer and sole to that particular block device. And so that's something that you should keep in mind. There are some features like this is one of the things that we built into Google Container Engine, is that a network block device on Google Container Engine can either be mounted read-write to one VM, or you can mount it as read-only to a bunch of VMs. And so that's a feature that fell out of the way that we did what we call persistent disks in GCE. Not all clouds support that, though. I don't think, at least last I looked, I don't think that Amazon or EBS supports that type of mode. All right, so you take a look at a pod, and it's relatively simple. So a pod is a workload that runs on one machine. You can pair a pod with a persistent volume, either through directly or through a persistent volume claim. And those things get paired one-to-one. And when you delete the thing, it actually detaches, and then you can reattach that volume someplace else. And so this is really similar to a virtual machine in some ways, right? You bring up a VM, you attach a disk, you shut down the VM, maybe you delete the disk, maybe you actually leave it. Parthenon says, do you foresee deconstruction of StatefulSet primitive in coming release? I haven't been tracking it that carefully. I wouldn't imagine that. I haven't heard any rumors of anybody doing any sort of big reinvention or rewrites of this stuff. So I don't think there's any big changes coming down the pike, but I could be wrong. Okay, so but the problem now is that now you have a pod, and we know how to pair that with a persistent volume. But now you get to replica sets, right? And so replica sets have this nice, they do a couple of things. They let you scale something out. So you can say, I want to run 10 of these things. And then they also do sort of auto replacement. So I want to run 10 of these things, and I want to keep 10 of these things running, even if some of them die or disappear. So replica set is a core primitive for self-healing. And so what you found is that before we had stateful sets, if somebody was doing stateful workloads, they would create a replica set with replica count of 1, and they would use that to run a pod with a persistent volume. And that way, if that pod died, it would, the replica set would be the thing that would resurrect it someplace else. Bruce, I'm sorry that I had the time wrong in YouTube at 1:30 when I was talking about it to other folks. And I've always done it at 1, but I had the time wrong in the YouTube thing when I actually sort of configured YouTube. It's kind of a little bit manual to set up each one of these broadcasts. I set it to 1:30, so I apologize, Bruce, if you missed the beginning. You can go back and try and watch and catch up, or you can, maybe catch up with the recording. So sorry about that. For those of you watching the recording, ignore what I just said. Everything went as planned. All right, so all right, so replica set. So before we had stateful sets, you had a replica set, and you'd do a replica count of 1, and then you test the persistent volume for that. If you did a replica count of 2, like bad things would happen because you'd schedule 2 pods that would then reference the same persistent volume, and then like the Kubernetes would be like, that thing's already in use, I can't launch it. So that means that your second pod would never actually launch. And so the problem is that we didn't have a replicating, we didn't have a controller that was similar to a replica set that also took into account the fact that you wanted to manage not just an array of pods, but you wanted to manage an array of persistent volume also, right? Or persistent volume claims. And so that's really where stateful set came through. It's like, okay, what I want to do is I want to launch 10 of these workloads, and for each of those workloads, I want to give them a volume, right? And I want to give them a volume through a volume claim. And so that's the core idea of what a stateful set does, is that it not only replicates the pods, it also replicates the volumes. Now, along with that comes some other features that really work well with these things. Most of the time, if you're doing replicated volumes, because those things, each instance of the workload, each replica will be storing some unique data. What you want to do is you want to be able to address those things directly, right? So you get this idea of, I want to give these things predictable names, and I want to be able to address them directly, because a lot of times you'll have something, I'll say, oh, I want to look up this data. I'm going to go to instance number 3 of my array of stateful pods. Whereas if it's a stateful thing, I just want to go to one of them, right? You don't care. So you get sort of more of a spraying type of load balancer typically when you're running stateless. And so predictable naming of the things that you're managing. And so with a replica set, when it actually creates replicas, it just gives a random name to each of the 10 replicas that you're creating, and there's no implied order. These things are all part of essentially what's an unordered set. And there's no guarantees about the order. But with stateful sets, what you'll see here is that when you start them up, it'll be like the name of the stateful set, and then they'll be ordered. They'll have an index, 0, 1, 2, 3, 4, etc., that they'll be able to then actually reference. And so that ends up being a big part of it. And because of that, it actually means that the way that you bring these things up and scale them down is a lot more rigid, right? And so you always start with bringing up sort of like, index 0, and then index 1, and then index 2, et cetera, et cetera. And then when you scale it down, you go in reverse order, right? So you'll always have essentially dense numbering from 0 to up to how many replicas you have, or replicas minus 1. And so once you introduce that ordinal, you really want to have some expectations around sort of how these things come up. And, if you scale down, you have predictability of which one you're scaling down, that type of thing. Now, this is actually how Borg works inside of Google. Everything inside of Google essentially has an index. And what it means is that there's a little bit less flexibility when it comes to being able to scale things up and down inside of Borg. And so this sort of very deliberate ordered scale up, scale down is actually more typical of the way that Borg works inside of Google. And so, yeah, so these things are stable names, stable network identities, and then we'll once we bring up CockroachDB, which uses stateful sets, we'll start exploring some of the aspects of sort of how a stateful set works in practice. So, so that's the TLDR of this stuff. Okay, the one last thing I do want to mention here is that when you do this stuff and you scale down, or when you delete a stateful set, it doesn't delete the persistent volume claims. And so the idea is that the stateful set errs on the side of not deleting data that you actually might care about. And so that's something that you have to keep in mind also, that deleting the stateful set does not necessarily delete the volumes that are sitting behind it. And yeah, and so there's some other sort of, options and stuff, like this idea of rolling out a canary, and there's rolling updates. So one of the things that I think is I don't know if it would be possible to break it out, but with stateless things, we have replica set, and then we have deployments, and replica set maintains a set of things, and then deployment rolls these things over such that you can sort of like, do a rolling upgrade by reducing the previous replica set count and then increasing the replica count of the new replica set. And that's how you essentially do a rolling upgrade. The rolling upgrade, the upgrade strategy for stateful sets is built into the object. So it's kind of like a deployment plus replica set that have been sort of smushed together and combined. And my guess is that you need to do that because of the strict ordering about how you actually start these things up and down. Drissel from the Netherlands, welcome. All right, so yeah, so there's all sorts of strategies around rolling out and then deleting. There's a note here where it leaves the PVCs around. Yeah. So there's other details there. I'm not going to sort of go through all of this. And then there's some examples here in the documentation. So preventing volume deletion might become handy. Yeah, so I think by default, it just doesn't delete the volumes, which is really nice. There's examples of running like MySQL or Cassandra or Zookeeper with these things. These examples are useful, but I don't know if they're as useful. Well, I was looking at the Cassandra one, because like what you'll see here is that a lot of the logic for how you run Cassandra in this stateful set is bound up in this image, and this tutorial, this example, doesn't go into a bunch of details around sort of what's happening with that image. But what you see here is that there's like, if we start digging into this example, there's like a run.sh, and so it's doing some stuff to essentially adapt Cassandra to how the stateful set works, right? So it's doing a whole bunch of goop before it actually launches Cassandra. And so what this shows here, and again, I don't think the examples go through a lot of detail. They make it look easier than it really is. What these examples show is that most traditional sort of replicated databases, right? Because like most of the time we're talking about databases here or data stores. They're either like single instance, right? Like say, WordPress or MySQL with, let's see, where is it? WordPress, MySQL here, it's service, PVC. So, this is a deployment, but then so you either have like one thing that you're dealing with, or what you find is that you need some level of scaffolding around the application to really make it run well in a stateful set. Because as you add and remove and scale up and scale down, or even establish the first relationship between the members of the database, that ends up being sort of one-time management operations. And so it's really rare to see databases that natively know how to work with stateful sets. Most of the time you need some level of code, an adapter that's going to be doing some level of management outside of the database itself. And so stateful sets end up being a useful building block for doing stateful workloads, but it doesn't solve the entire problem. You still need to do some management and some plumbing. And so when I was going to be talking about this, the Jetstack folks, our friends at Jetstack, wrote and wanted me to bring up. This is really interesting. This is this thing called Navigator, which is a system that, using things like StatefulSet, manages databases, right? And so this adds a lot of that extra knowledge, that domain-specific knowledge about, okay, for, Cassandra, for example, it's not enough to just sort of launch a bunch of processes. You also have to sort of stitch them together and poke them in the right way and manage them in the right way to make them work well inside of Kubernetes. And so this is all of the automated code. Now, I haven't used this yet. I'm really interested in checking it out at some point, but I figure this is a good example of how you do need some relatively sophisticated adapters to make a traditional database, or at least a scale-out database, or something that's doing replication, to make it work well inside of Kubernetes. Yeah, so check this out. It looks really interesting. Again, I haven't used it, but it looks really cool. And this is also an example of something using the kube aggregator, which is a sort of more full way of extending Kubernetes. It's also more difficult to manage too. So, yeah. Abdel says, I love the stateful set, but why doesn't it delete the PVCs? I think it's just a matter, honestly, of being paranoid, right? Because if you have state, it's because you want to actually keep stuff around, and it's too easy to accidentally delete something and then have that go ahead and delete the PVCs on you. So really, I think it's just a matter of being paranoid. I could see, let's see, I could see. And maybe, I'm sure somebody has proposed this, I'm not aware of it, of having some sort of option on a stateful set that says delete the PVCs when you're done with them. But the scaling down section, what does it say here? It says ordered pod termination, stable storage. I don't know. So I'm just reading through I don't know. My guess is that, err on the side of not surprising people and not... Yeah. So again, not the expert hit there, but again, my guess is that it's just outright paranoia. All right. So that's where we're at. So I think that's my intro to stateful sets, but I think it's useful to see this stuff in action. And so I'm going to be playing with this project. Anthony says, if you prefer to delete PVCs, you could try cat set. Oh, is this? All right. So this is a bad joke that Anthony's making here, because before stateful sets were stateful sets, they were actually called pet sets, which is playing on the whole sort of pets versus cattle terminology. Whereas each of the items in a stateful set are not sort of purely cattle, because you do want to actually manage them. So they really are pets, but it's a set of pets. Right, but then Anthony has, and we did the episode on the meta controller, and he's continued to work on this, and I haven't looked at it recently. This is, yes, and now it's in the KS temp. Is this because figuring out how to actually get it into the Kubernetes? Okay, so now it's in the KS temp org, which I'm not sure why it's there, but I think, let's see. Yeah, so Anthony has an example of a thing called cat set, where he essentially re-implemented stateful sets using the meta controller, which I think is a good proof point for the meta controller. And you can tell that it's actually not as hard as you'd want it to be. I don't know if it's totally feature-to-feature thing, but it definitely hits the same usage. Jay Hernandez says, what about multi-AZ deployments? I believe that stateful sets track zones. I don't know. Do they track zones? It's not in the documentation here. My guess is that, well, usually what happens is that when you actually create a PV, whatever zone it lands in, that's actually where the stateful set, where the pod gets scheduled also. Yeah, Anthony says, pay no attention to the weird org name behind the curtain. I think I know what happened there, Anthony. I'm not gonna go into the details there. So I'm not exactly sure about what happens with multi-AZ deployments and stateful sets. I mean, the truth of the matter is that if you're managing state, you probably want to be very zone aware. And so I would be, I would probably run a stateful set per zone is the way that I would start looking at it, and then I would have zone constraints on the stateful set. And if you're doing things across zones, then you know, do that expansion there. Sandy says, I think there were some special cases put into the scheduler to look at stateful sets PVCs differently. Perhaps. I mean, perhaps they try and get some zone spread across these things. That would make me sad if there was actually special cases put into the scheduler, because that's a layer violation. That is a lazy shortcut. Yeah. All right. So Bruce says, are there any performance numbers with respect to PV, disk I/O, whatever? It's the underlying cloud platform. I mean, there's like a gazillion different sort of adapters for how you do PVs. You know, typically they work over the network, and so you'll definitely see performance issues like however fast your network is. There is a feature that I believe is alpha in 1.9. I'm not sure. I'd have to look it up, for essentially having a persistent volume that's local. And so I think that's going to be really interesting when you combine sort of, you know, semi-persistent but non-replicated local disk with stateful sets, and things like Cassandra or CockroachDB that do their own replication. So right now what happens if you run something like Cassandra on top of Kubernetes and you're using something like EBS volumes behind the scenes, you're doing like double replication, right? Because Cassandra itself will do replication, but then the block storage that it's using under the covers, like the EBS volume, is also doing replication. So that ends up being slower and wasteful. If you look at folks who are doing sort of like really big Cassandra deployments on top of Amazon, like, you know, say like Netflix, they will always use like these you know, local flash devices that are on these big instances, and they'll buy the whole instance, that type of thing. And that's one of the big reasons why you end up with like local flash on GCE also. So the local PV volumes are really, really interesting. So Bismarck says, okay, so are there any tools out there to audit PVC for orphans? I don't think that there are. Well, what you can do, we'll play around with it when we delete the CockroachDB stuff. I believe what you can do is you can list your PVCs, and you can actually see whether they're attached to a pod or not. I think you can do that. I don't know. Let's check that out and see what happens. But and then Bismarck says that topology-aware volume scheduling is going into beta in 1.10. So hopefully that'll get rid of any of the sort of layer violation hacks that were put in there for stateful sets. Okay. All right. So the interesting thing, so let me rearrange my tabs here, because I'll include the meta controller cat set stuff that Anthony mentioned. So the interesting thing with CockroachDB is that it's inspired by systems like Spanner at Google, and it's built to be distributed from the get-go. But because it's a relatively new database that sort of came of age in a world with dynamic schedulers like Kubernetes or Swarm or DCOS or whatever, and because it's heavily influenced by experiences of running similar systems in something like Google, there's an opportunity to have CockroachDB be much less, require much less sort of outside coordination to actually get it set up and working. And so what you'll find as we go through this type of tutorial is that you end up with a certain amount of automation here out of the box with CockroachDB without some sort of external operator type of thing that's working with it. And so I think this is a pattern that we're going to see over time, is that we're going to see more and more systems like Cockroach that are built to take advantage of distributed platforms from the get-go. So instead of having to build up their own sort of like distributed paradigms, they can take advantage of an underlying platform like Kubernetes. And so I think that's going to be a really exciting development. It's going to lower the bar for people doing more and more stuff like this. All right, so we're gonna launch CockroachDB, and there's this really great tutorial that they have, so it starts with starting Kubernetes, but I already have a cluster up and running, and since we're going to be playing around with stuff, I launched a cluster with, I believe, like 5 worker nodes. Q control get pods or nodes. Yeah, so we have enough nodes so that we can start playing around with stuff. Kid from Naperville, good to see you. All right, so that's our thing. So it turns out that this is actually really, really easy. It's not going to take us that long. I did this while I was waiting for the delayed plane last night. So the first thing it does is it says, like, you know, do a kube control create -f, which we know is like, you know, sudo curl pipe to bash, or curl pipe to bash type of thing. But so we're gonna look under the covers there, and we're gonna do curl, and we're gonna download that thing, and that got us CockroachDB StatefulSets secure.yaml. And so let's look to see what's in this. What happened to my? We'll just, oh, what is that doing? It's not what I wanted. I want code and then dot. All right, that'll work. I can't type today. All right, so there we go. All right, so here's what we got. We got CockroachDB StatefulSets secure, and what I love about this is that this is actually well commented. There's a lot of comments in this YAML that tell us what the different options do, which I think is really, really, really interesting. So that's really cool. The next thing that I think is interesting, and we'll get to this, is we're doing the secure deployment of CockroachDB. It actually uses some other APIs, the certificate signing API in Kubernetes, to create certificates that it can use to talk between the instances of Cockroach. And this starts to hint at the types of things that we'll see as we see the idea around what we've been calling container identity and systems like Spiffy, which I've talked about before. As those mature, a lot of the steps that we're doing here to actually allocate and approve these certificates will disappear, and this will be stuff that the system will be doing for you automatically. All right, but let's go through and look at what it's doing here. So we have a service account called CockroachDB. It's not talking about any specific namespace, so this will run in whatever namespace you give it. So we're going to be running it in the default namespace. We have a role. So this is not a cluster role. This is a regular role. So this is something that's local to this specific namespace that we're deploying this to. And I love seeing this because that means that it's very easy to isolate it. If you wanted to run your Cockroach instance in a different namespace, this is all very local to that namespace. And so that's really great. And so this is saying that it can both get and create secrets. The reason why it needs to do this is for storing the private keys of the certificates that we're going to be creating. And so that's why it needs to be able to essentially interact with the Kubernetes API directly to sort of get and create and delete those secrets, or create and manage those secrets. Again, when we have workload identity, we're not going to need this stuff. And then there's, essentially create, get, and watch their certificate signing requests. So this is so that I can submit certificate signing requests. And then that is a cluster role, but we're doing a role binding, so only so we're doing the role binding of the original role, and then we're doing a cluster role binding of the cluster role for that. So these are very narrow set of permissions that we're giving Cockroach. So we're not giving it a lot of permissions on the cluster. And then the next thing here is that there's a service over this thing. And let's see, it says this service is meant to be used by clients of the database. It exposes a cluster IP that will automatically load balance connections to different database pods. And so apparently, and I don't know the details because I'm not an expert on Cockroach, but when a client connects, it doesn't matter which of the nodes it connects to, they're all equal in terms of being able to do queries. And so this just says, hey, talk to one of them, I don't care. And there's both, there's a gRPC port, which serves a sort of Postgres flavor SQL. And that's also used for internode traffic and the CLI. And then there's another port that serves a UI. You'll notice that these things are, they don't say what type of service it is, so it defaults to a cluster IP service. And then there's another service here, and this is used for talking to specific instances of these things. And what you'll see is that this service only exists to create DNS entries for each pod in the stateful set, such that they can resolve each other's IP addresses, so that's so they can find each other by name. It does not create a load-balanced cluster IP and should not be used directly by clients in most circumstances, because most of the time you don't need to be able to talk to the clients directly. And then there's an annotation here, and this is a hint to the DNS system that's actually reading these services, that says that we want to tolerate unready endpoints, which means that even if a particular endpoint is unready, still put it into DNS. And so this changes, because, okay, a little bit of a backup. So when you do a service, you actually say, okay, all the pods that meet this particular criteria, I want to publish those things and give them a name. So that's the core thing that you do. And then what happens is that Kubernetes goes through and actually creates a buddy endpoint object that sort of hits buddy to the service. That endpoint object contains details about all of the pods that you identified with that thing. So one way to think of a service is it's a standing label query. One of the details that gets surfaced in that endpoints is which of the endpoints are ready versus unready. Now, there's also one of the things that kubeDNS does is it takes these things and it exposes them via DNS. Now, if you're using a cluster IP, DNS is that cluster IP, so it essentially becomes a very simple mapping. If you're not doing a cluster IP, then what you'll see, and we'll play around with this, is that the DNS name for the service ends up being a list of A entries, and it'll typically only include the endpoints that are already there. And this is saying, no, I want to include all of the endpoints there. This is an alpha. I think I saw with at least the latest releases that this has been promoted to GA, and so now it's not an annotation anymore. But there also looked like there might be some bugs with that. Let's see some annotations on here to help Prometheus work, and then those same ports that we had before, we're exposing those in this headless service. But here we're doing cluster IP equals none, which essentially says don't give it a cluster IP, and it becomes a non-cluster IP service. Saeed says, volumes can be automatically deleted if they were dynamically provisioned and they retain policy set to delete. So that's when you delete the PVC. There's a question of what happens to the PV when you delete the PVC. I think the question with StatefulSets is that when you delete the stateful set, does it delete the PVCs that are actually keeping that claim? So there's sort of two levels of auto-delete that we have to consider here. How's it going, Marco? But we'll definitely play around. And then here's another object that we haven't talked about a bunch before, which is this thing called a pod disruption budget. And this essentially says, hey, system, to the best of your ability, try to make sure that there's never more than one of the pods that meet this selector down at a time. And so this means that like whenever you're doing, say, like a node drain, I believe node drains use this, or I believe this gets used with things like the cluster rescheduler. You're like, hey, I'm about to delete this pod for sort of maintenance reasons. Will it violate my pod disruption budget? And if the answer is yes, well, then you wait until things change and you try again later. So it's a way to make sure that you don't take down too many things at once. So what you'll see is that there's a bunch of features, both the way that PetSet rolls things out very deliberately and things like pod disruption budget, where whenever you're dealing with data, whenever you're dealing with stateful services, things move a lot slower than where you're dealing with stateless things. And that's because you want to make sure that you have enough time to copy data around, to do handoffs, to make sure that not too many things are down at once. And so things tend to move slower, and you tend to be more deliberate when you're dealing with operating stateful services versus stateless services. All right, and here's the stateful set itself. We're going to be doing 3 replicas. It has the service account name. We have an init container. This thing is actually going through and creating a certificate request for us. We'll get into some details there. Caleb, good to see you. It's doing some downward API stuff where we're actually populating some environment variables from other things in the pod specification, and then it's mounting this this volume called certs. And then, and then here's something that's interesting. It has a pod anti-affinity to say that as much as possible, we want to make sure that these things don't land on the same node. So preferred says like, hey, if you can't do anything else, go ahead and do that. But all things being equal, we want to make sure that we spread these things across host names. And then there's the main CockroachDB container. It has its data container, which is the persistent volume. But then it also has an empty volume, which is certs, which gets populated by this init container here. All right. And this essentially goes through and starts up CockroachDB and has a join a cluster, and there's some tunables there on the command line. And then there's no explicit pre-stop hook. SIG term that Kubernetes sends typically when it's bringing down a service is good enough, but you want to give it 60 seconds to be able to do its graceful termination. Kyle says, it looks like they have 2 service definitions. Could they have created the DNS entries with just the first one? I believe that when that the DNS system acts differently when you do cluster IP. And when we spin this up, what I'm going to do is I'm going to launch a kuard, which has a interactive DNS agent, and we'll start exploring what DNS looks like. And so we'll look at the differences in terms of how these different services get exposed into DNS. Yeah, and then here's the volume claim template that we have. Okay, and it says we're going to do 1 GB of storage for these things. All right, so that's super cool. Let's go ahead, kube control, apply -f, CockroachDB StatefulSets secure. This is going to do its thing. Oh, and let me do, I always forget the shortcut key for this. View, no, shell, there we go, split horizontally. We'll do another sort of present shell down here, cd tgik. All right, we do that. Okay, so we're gonna do watch. All right, so we're gonna be watching the pods. Actually, let's do pvc. All right. So what we see here, so this is the watch command, which you can install on your Mac with brew, says execute this command every second and then give us the output. And so we're going to be watching sort of what the state of the pods and the PVCs as we go through here. Lamati says, how do readiness checks play into stateful sets like CockroachDB? May have missed it, but I didn't see a readiness or liveness check in the YAML. That's a good question. Did we have one in the YAML? I thought there was. You're right. There is no readiness or liveness check here. Yeah, that's interesting. It says, yeah. I'm surprised that I don't see that there. I would expect to have seen one there. So that's interesting. Have to talk to those folks and see what they say. Kyle says, if you ever make a TGI Kubernetes shirt, it should have that shortcut on it. Which shortcut? The watch shortcut? Yeah, I do want to make T-shirts at some point. I think we should totally do that. Okay, so now what we have here is so Alex says, Alex is the one who did a bunch of this. No readiness liveness checks at the moment will be added after the next release of Cockroach. Okay, so those are coming. That's a good point though, Lamati. Good eye. They're coming. All right, so. If we go back to the tutorial here, you'll see that there's this thing saying we want to approve the certificates. So what we have here is we can do kube control get CSR. That stands for certificate signing request. And this is the way that public key encryption should work. Not everything follows it, as evidenced by some drama in the PKI world this week. But what happens is, and I'll just sort of this is some PKI 101 for folks, is that if you want to create a certificate, there's a couple of things that you want to do. So you want somebody to attest to sort of your identity, but you want to also make sure that none of your secrets, none of the secret stuff actually flows across the network or leaves your machine. And so what you do is you create a public-private key pair. So these are the sort of two big prime numbers typically with RSA. You take the private thing and you keep that local on the machine. So you never want it to leave the machine if you can help it. You take that public key, and that's the thing that you want somebody to sign. And so you package that up using a specific format that says, please sign this, and here's the certificate that I want you to create around that. And then you hand that off to somebody else. You get approval via some mechanism, and that's kind of left up to the reader. That then goes ahead and approves it, and then it delivers to you essentially a certificate that says, hey, this public key here that's embedded in the certificate, I'm going to attest that actually I want to say these things about it, and then it's signed with my private key. And so whoever you're submitting that to signs it with their private key. And so in this role, what's happening is that the individual pod for CockroachDB is creating a certificate signing request, keeping the private key local, putting the public key up to an API, and that API happens to be embedded in the Kubernetes API server. And then it's the Kubernetes API server that's playing the role of certificate authority. It's going to, again, sign this thing and return it. And so this is typically used for bootstrapping a cluster. Using it this way is honestly a little bit of an abuse of this API. It's not what it was intended for, but it totally works, and it's a great thing to do while we wait around for the rest of the workload identity stuff to actually get its act together and get done. So what we'll do is we'll do get CSR, and what you'll see here is that we have CSRs for each of the nodes. So this is like when I talked about bootstrapping, this is how individual nodes actually sort of bootstrap their authentication and their credentials for talking to the API server. But we actually see one for CockroachDB here also. And we can inspect that. So I can do kubectl describe CSR, and then we'll look at that. And what you'll see here is that this thing has who requested it. So this is the service account that was used to request it. And then what are the names that we want this thing to be able to work under? And so there's localhost, which is kind of a little dicey, CockroachDB, both a short and a long name, and then CockroachDB public, which is that common service that people are going to be using to talk to it. And this should probably use the long name too also. Oops. And then IP addresses that you want this thing to be able to assert also. And so then what we can do is we can do kubectl certificates, certificate approve, and oh, not that. And let me copy this. So now we do that, and now when we describe the certificate, we can see that it's approved and issued. And if we go through and you'll see that's there too. Now if we look at this, so now what you'll see is that because we approved it, instance 0 finished launching, and now instance 1 is in that same state. But if we go ahead and if we actually get CSR this, and we dump the YAML, what you'll see is here is the request, this is the CSR, and then after it's approved, as part of the status, there's the certificate that was actually issued. And so if you know all the super duper cryptic flags for the OpenSSL command, you can like decode this thing and figure out what it is actually saying. And so yeah, the CSR was approved by kubectl certificate approve, because that's we manually approved it. Now you can write API-driven things that look at it and say, hey, that looks good enough, I'm going to go ahead and approve it. You can have the request have extra information in it that you could use to prove things. And so this is some of the bones to start automating an approval workflow for this. Okay, and so now, oh, and then the next thing that you'll see is that, like, you know, there's the certificate, which includes the public key for this particular identity, but then there's the private key. Now we could keep the private key local, but then if something died, if that workload died, then what you would find is that private key would be lost, and we'd have to go through this dance again. So one of the things that you'll see here is that the bootstrap stuff for CockroachDB also takes that private key and then stores that into a Kubernetes secret that's accessible by the service account. So we're not getting as much sort of individual sort of identification as we'd want. Like I said, a lot of that will come with the container identity stuff. But if I do kubectl get secrets, what you'll see here is that we have the secret for the private key. And if I do kubectl get secret, here's the certificate. So this is the same thing as we had up here that was issued. And then here's the private key that matches that certificate. All right, so that's the flow. So let's do kubectl get CSR, and then approve, and we'll do approve 1. And now what happens is you'll see this pod initializing. It'll complete, and then we'll see CockroachDB 2 actually complete. So we'll ask for a certificate. We'll go ahead and we'll approve. Oh, no, it's still getting its act together to even submit the CSR. It's probably downloading the image. There we go. Now it's pending. All right, so now that's approved. This thing will now go into pod initializing. And if I go get secrets, what you'll see is now we have these three things that are running. All right, so we're most of the way there to actually having a CockroachDB cluster up and running, but there's one step that we have to do here, which is actually tell this thing to initialize itself. So there's another YAML file that we're going to take a look at. So I'll do curl. We'll take a look. This is cluster init secure. And what this is doing is it's running a job. That job actually is using another cert, so it's going to request another certificate, and so that's the an init container, and then that's going to run, and that's going to call using the Cockroach client and that certificate. It's going to say init to this particular host thing, and then that's going to be enough for these things to stitch themselves together. So let's go ahead and apply kube control apply -f, and this is cluster init secure. And what we'll see is that, oh look, we have the that thing running. It's that init container will get to enough that now we have a pending thing for root. Now this is interesting here. Kube control, and this is one of the sort of weirdnesses here that I'm a little uncomfortable with. But if I do a describe this thing, you'll see that the common name that this is using is root, right? Now this isn't saying it's root for CockroachDB. This is saying, hey, you common name root is now approved for using the CA for your entire cluster, which means that I could then go ahead and take the certificate to use to talk back to my cluster, and if I have RBAC set up to actually recognize a user named root, which is not insane, then this certificate could be used to talk to that. So I'd much rather see this say something along the lines of like root at or root dot and then the name of the cluster that we're actually talking about, which will scope this identity down to something that's much more specific to this cluster and isn't likely to clash with other identities that might be running in my cluster. But to do so, I assume that a common name of root carries special meaning with the CockroachDB code. And so that means that probably would require another flag in the CockroachDB code to recognize, hey, which identity do you want to give root to? But for now, we'll just go ahead and ignore that, and we'll approve this thing anyways. Certificate. All right, so that's actually now running, and that'll actually go through and do the initialize. Maybe. Something going wrong. Yeah, okay, that ran now. All right, so now I think we have a fully functional cluster. Let me go back and make sure I didn't skip any steps. All right, now we can test it. So the next thing we're going to do, and this is kind of a little bit interesting, is let's see. Let me get this URL here. We'll just copy this. Curl. All right, so we have one last YAML file that we're going to look at here, and this is client-secure.yaml. And what this does is it brings up essentially a container that does nothing but sleep for essentially forever. And so this will sleep for a long time. It's interesting that and then so you're like, well, why would you want to do that? And so this is so you have something that you can quickly do a kube control exec into and start working with interactively. So it's essentially a sort of like a little footprint on the cluster that you can then start interacting with. And so that already has all the right tools installed and available for you. You could probably do something similar where you're actually calling the CockroachDB client. You can probably do like a port forward type of thing to one of the nodes, and then have the client run locally and using the certificates that way. It might be cool if the CockroachDB client actually was Kubernetes aware enough that it could actually go through and use your kube control and actually create its own tunnel, its own port forward tunnel through the thing. So that would be kind of cool too. But so what we're going to do is we're going to go ahead and run this thing. And so this thing is called client-secure.yaml. And you'll see when we get this thing up and running, there we go. And now what we can do is we can do this kubectl exec thing. We'll copy this line. And so it says, okay, I want to do an exec into this client secure thing, and the command I want to run is Cockroach SQL. It can tell it where the certs are and where to actually find the cluster. So we go ahead and run this, and boom, we're at a prompt. We can start doing Cockroach SQL with this. And so they have some example sort of commands that we may want to run here. So I can go, well, if I copy, does it? Oh, look at that. Okay, so we created a database called bank. Oh man, I'm going to be so rich. We're going to create a table called accounts, which has both an ID and the balance. You probably, in the real world, you'd want more than that. And then we'll enter some values there. Account number 1 has 1,050 cents. Let's do 100,000. Boom. All right, and so this is decimal. So yeah, so we actually have like real banky types like decimals in there, which is cool. And then we can actually query this too, and we say, okay, we can do a query. And I love how it tells me how long each of these things took as we go. So yeah, so we have a database, and it looks like, so if I try and insert it again, it's like, I'm sorry, you have a duplicate primary key value. So this is looking very databasey. Apparently it talks sort of like Postgres compatible API, so you can reuse a bunch of the clients that you have. And this thing is distributed across a bunch of nodes. All right, so that's kind of cool. And then, let's see, and then we can do this port forward to one of these things, and we'll hit 8080. And so Krista says this is looking very databasey. All right, so we're going to do, so this is fascinating to me. So we hit 8080 HTTP, but then it like upgraded us to HTTPS. And so we have to say, we'll trust this anyway. So it's actually not an HTTP, it's HTTPS there. And then this is actually a really cool dashboard that Cockroach has. And so we can tell sort of like how much capacity we're using, latency. So there's a bunch of really good information here. I can go through and explore the databases and actually go through and look to see which users can do what. Here's sort of the table schema. So that's pretty cool. There's jobs. I assume these are like maintenance things that are happening in the background. I'm not sure what jobs are. But one of the things we can do is we can look at the node list, and here's the nodes that we have. And then we can even look at logs. Look at that. That's fancy. These logs, these must be get written into the database also. Huh, interesting. Lamatti, what options are available to interface with CockroachDB from outside the cluster, which would be a good use case for ingress? I mean, since everything is nice and TLS-y, right, and encrypted, it's not crazy to actually sort of like make this available over something like ingress to the rest of the world. But it's generally not what you do. I mean, like, it smells really bad, even if you're, even if you're protecting it with TLS, to have your database exposed to the world in any way, shape, or form. And the reason being that, like, there's still an opportunity for somebody to do sort of a denial of service type of thing directly to your database. And so I wouldn't go through and expose this directly to the internet. What I would do though is for sort of interactive things. The stuff that we're doing here is great for, like, manual type of interactions with the thing. Port forward's really appropriate. Maybe if you're, if you have a VPN into the network where your cluster's running, you could do a node port for the thing. That doesn't seem crazy to me. But I wouldn't expose it to the internet with something like ingress. So if you're doing like an internal ingress, because you can do ingress for internal versus external, then maybe that makes sense. But typically, you'd be accessing this from within the cluster. So you'd like bring up like, a Python program or, a node program that sits right next to Cockroach and actually talks to that directly. Let's see, and so Parthamon is asking, Does CockroachDB and Spanner share the same API and SQL version support? It looks like SOL version support here, but I think it got cut off in the thing here. I don't know. I haven't played with Spanner, to be honest, or at least the Cloud Spanner stuff enough to tell you. So Alex is saying here is that CockroachDB targets PostgreSQL compatibility, doesn't support Spanner's gRPC API. And I think that's a really smart thing for the Cockroach folks to be doing, because you're going to find a heck of a lot more PostgreSQL clients out there, and ORMs and all that stuff than you will the Spanner gRPC stuff. All right, so we have a database up and running, or at least I think we do. It looks really reasonable to me. We haven't beat up on it too hard. So there's a couple of things that I want to do here. If we go back here, you can simulate a node failure. We'll get to that. One of the things that I do want to do is I'm going to shut down this the port forward. Let me go through. I'm going to launch a kuard, but I need my cheat sheet here to be able to do this. I need fancy copy things like Alex has on his page. Okay. So now I'm instead of port forwarding that port to the Cockroach thing, I'm gonna forward this to what? Oh, it's trying to do HPS. It's not HPS. I want to do HP. Boom. Oh wait, why is it? Oh man. All right, so Alex, here's a bug report for you. If you see somebody coming in on localhost, do a 302 redirect, not a 301. Okay, and then Bruce says there's more stuff because now this thing is actually being like, hey, I know that 8080 is always going to go to, so I'm going to do 8081. So now my browser is tainted and I can't do regular old HTTP on 8080. So that's annoying. All right. So now I can go through it. I can do DNS. And so this is something I built into kuard. And if I do an A on Cockroach public, was it Cockroach public or what was the thing called? It was, what was the services? CockroachDB public. So if I do a query on that, what you'll see is we're going to get the regular old cluster IP. If I do a serve record on this, same old thing. We're going to get the cluster IP. And so when you have a cluster IP, DNS will only ever show the cluster IP. So this is why we have two different services. Now, if I go through and if I do an A record on CockroachDB, what you'll see is I get 3 A records back when I do that A query. And these are the 3 individual instances of this thing. Now, when you do an A record, you're actually going to be getting, they all have the same name. So all we know is that this name resolves to any of these 3 IP addresses. And there's limits to how many of these things you can return, because if you had I don't know, 1,000, at some point, they don't fit into a response from DNS. Now, if I change this to a serve record, what you'll see here is now the serve record says, hey, this thing actually resolves to the individual names, and then I can go ahead and here's the IP addresses of those individual names. In addition, if I want to talk to those things directly, the DNS will, I can do CockroachDB-0.cockroach. Oh, this thing should be longer. DB, and it'll actually, so not only do we now have on that internal facing service, not only do we have sort of the serve records and the A records that returns all 3, but we have individual DNS records for each of the instances. And so you have a direct accessibility here that really facilitates StatefulSets talking to each other and creating essentially crosstalk as they do replication and stuff like that. And so this is what's happening with the DNS, and this is why CockroachDB needs 2 services, because it has the external service, which has everything, all the details get hidden behind the cluster IP, and then the internal thing, because it doesn't have a cluster IP, all the details get exposed, but that's what we want so that the internal parts can talk to each other. All right, so let's go through, and let's do the port forward back to CockroachDB. Oh, now, okay, let's see. Boom. And, okay, and then also, apparently, if I go to debug, there's all sorts of good stuff. Oh, look at that. So there's reports and tracing and stuff like that. So all sorts of really cool stuff here for figuring out what's going on. So there's like a gossip thing. So this is like some of the sort of raw API type of stuff. So one of the fascinating things about CockroachDB is that it does synchronous replication across nodes. And so you get a certain level of predictability. And it actually uses the same algorithm as etcd, but it's built for sort of scaling out as a more realistic database. And so it shares some of the underlying sort of algorithms, and even there's a shared library between etcd and CockroachDB. And that's this algorithm called Raft. And so Raft is a consensus algorithm. It's a way that you can, essentially get a group of things to agree that something is true. And so what that means is that CockroachDB is consistent. But one of the problems with Raft is that it doesn't scale up because the idea is that everything that happens in your database, you give it a very concrete sequence of this happened after that. So what you say is that the database provides a sort of an absolute sort of sequence order of what happens when and where. And the more things that you put in there, the more difficult it is to actually fit all that into one sequence. And I may be screwing this up. I'm not a database expert. And so what CockroachDB does is it runs a whole bunch of sort of Raft algorithms. So you can think about it as like a bunch of etcds all running side by side. But one of the things that you get out of that now is that like it gets a lot chatty. If you're doing like, I don't know, 100 etcds that are synchronizing with each other, that gets really chatty. And so these guys did an algorithm called, I believe it was like multi-raft, where they find ways to compress and sort of minimize the amount of chattiness as you're doing sort of a parallel set of Raft algorithms. So scaling Raft. So there's a blog post a couple of years ago that talks about this stuff. This has been around for a while, and I believe that there's a shared library between this and etcd, or at least there was at one point. Yeah, so that's interesting. And so you can see that, like, okay, you can look at some of the status around this. I don't know what any of this stuff means. Prometheus metrics. So this is ready to be consumed by Prometheus. Here's some other metrics about sort of the GC metrics for Go. So all sorts of good stuff going on here. So yeah, super interesting. All right. All right, let's go through and let's kill a node, because that's how we roll. And we're going to look at the node list. Wait, is this? We're going to go to nodes, see where they all have these green dots here. For those who are red-green colorblind, I promise you they are green. And so the way that this has us do this is it has us just go ahead, and I'm going to move that background, and delete a pod. And so when we delete a pod, it's going to actually do a clean termination of that pod, because you can see it'll take upwards of 60 seconds for this thing to exit. But then what will happen is the stateful set will be like, hey, this pod disappeared, just like a replica set. It'll actually spin up a new version of that thing. So Lamati says, do all the nodes in a CockroachDB stateful set handle writes simultaneously, or is one node elected master and the others slaves or replicas? I believe it's like a multi-master type of thing, but Alex would be able to tell you more. Yep, you can see now this thing is yellow, which means that it's in trouble or it's shutting down or something. It's in the process of terminating. So let's see if Alex has any details on this. So this can take, because we have the termination grace period of 60 seconds, this could take up to a minute to actually have this thing gracefully shut down. And then what happens is Kubernetes takes care of making sure that it detaches that EBS volume from the node that this particular pod was running on, and then reattaches it to the replacement. Oh, yep, and now we can see that we have the replacement is getting initted. So it's got scheduled onto a different node, and now it's initializing. And we didn't have to do the CSR dance because it was able to actually pull the secret key from the Kubernetes secret. Let's see, and so Vivek says, it's multi-master so you can read, write from any node. Oh, and now we're back up and running. So what you can see is that the others have been up for 17 minutes. This one is a few seconds, and it's still coming up to speed here. And so I believe that there's enough replication between these things that the database would still be accessible. You wouldn't have any downtime, even though one of those nodes went missing. Now, if we took down 2 nodes, bad stuff happens. Now, this was a graceful shutdown of the thing. Let's see if we can be a little bit meaner to the thing. Cube control get pods. Right, so now let's see. So this thing now landed on this particular node, which is where my kuard D is running to, which is okay. Now let's go into EC2, and let's see if we can be ruder about taking down that instance. So this thing, what was it? It was 5.174. Where is that? Shoot. Do I have to, like, why don't I have that on here? We want to have the instance attribute. We want to have the VPC image. No. Host ID. That's not what we want. I want the private IP address because that's what we're going to use to identify this puppy. The private IP address is what I said, 5.174. So this guy. All right, so this guy here is running. What can we do? Can we instance state? I want to do like a hard terminate, but I think this still does a somewhat graceful terminate. Oh, Chris says I can just paste it in the search there, yeah. Okay, so we're going to terminate that, and we're going to say I want to delete the... I don't know if this will delete the... Let's see what happens. Okay, an EBS back, the root, so the root EBS will get lost. So we're going to go ahead and terminate this thing. So it's still doing a shutting down. So I think this does it's like you hit the power button and it actually shuts things down. If we wanted to be really rude, what we could do is like yank the virtual network cable by maybe going ahead and I don't know, taking down the network, or like SSHing into the node and taking down the network, or unmapping the ENI, the elastic network interface from the thing. But this is doing a shutdown. And now if we do watch kube control, let's see. So this is ready. This will take it a few minutes to actually sort of recognize what's going on here as this thing shuts down. Again, this is the sort of the nice way of shutting the thing down. Lamatti says, echo C, sys request trigger. Just disconnect the network. Yeah, exactly. Oh, wait, no, it looks like it's down now. So now that got removed from here, and it's terminated. And what should happen here is that this is in an auto-scaling set. And so Amazon should launch a replacement for this thing. Okay, now what we see is that CockroachDB 2 actually got rescheduled and run. So the database is up and running. So even though that node got yanked out from under it, Kubernetes took care of rescheduling that pod onto another node, right? And so if I go through and if we do wide here, what you'll see is now this one is on 21.111. And so it still maintained the idea that it wants diversity. It didn't place that on a node where we're already in a Cockroach DB instance. And then what'll happen eventually if Amazon gets its act together is that the auto-scaling group should recognize that, hey, one of these things is terminated, and then launch a replacement. But that hasn't happened yet. 4 of them. So eventually that'll happen. And then we'll see that kuard D, because I just launched kuard D as a pod, not as a replica set, it's gone. right? And so if I wanted to actually do that, I'd have to delete and relaunch kuard explicitly. If I'd launched it under a replica set, I'd be okay. It would have gotten restarted also. All right, so refresh. Let's see, refresh. That's not happening. Well, I'm doing a watch here, so that's happening every 2 seconds. Okay, let's see. Is this? I think I now have. I think it's probably launched. Okay, so it's now launched the replacement, and that replacement is actually initializing here. And so what this is going to do is it's going to rejoin the cluster because we're using kubeadmin here. As that thing comes up, kubeadmin join will rejoin the cluster using the token that we have. All right. So that's how it works. Let's try and be a little bit ruder about this and see what happens. Because this thing, so now let's, okay. Oh, I meant to delete this one. So I have, let's do, if I do this run tunnel thing, and then I SSH into this, now I'm SSH'd into the machine that's running CockroachDB 2. So if I do a Docker PS, we'll see, I don't know, if I go through this, we'll essentially see that this is the one that's running CockroachDB 2. Yeah. Okay, and then what's the easiest way to actually sort of kill this thing? I can do, like, does the echo C to proc sys trigger, does that actually cause the thing to like hard crash? I don't know. Or echo C proc. What does that do, Lamati? Panics the box? Oh, let's do that. Boom. All right. So we broke it. Okay. So if you do enter tilde dot, that exits your SSH session for those who don't know. But we were like 2 SSH deep. And so I think you have to do, if you want to exit one but not the other, then you do like tilde twice. All right, and so what should happen here, now this is actually much harder for Kubernetes to actually recover from. And I'll tell you why. Well, number one is that notice that this thing's not ready. And then you'll see that these things are now errored out. Okay, so that's all what we expected to happen here. Now, what should happen here is that we want to relaunch this thing onto another node, right? And so what will happen is that we're doing an init onto another node. So now this is running on 251.68. Now, the tricky part here is that it had to actually unmount and then remount the EBS volume onto the new thing. And so because that box was panicked, it's not clear if, like, you know, the cloud provider then has to be like, well, how forcefully do I want to unmount the volume from the previous guy, because he didn't do a clean shutdown of the thing, right? And so it had to unmount and then remount it, and there might be some issues around like running like, you know, checking the disk for integrity or whatever. But the idea is that eventually, yeah, so now we have a NIT error here. And my guess is that this error is around being able to go ahead and deal with unmounting the volume. So this thing is in a crash loop back off, and this thing's in an error. So we actually, a NIT crash loop back off. And so something's not going right here. Now, what we do have is that it's running on 68, or no, that's running on 21.111. So this thing is ready. It's been running for a while. Is that the one that I killed? No, that's not the one that I killed. And then if we refresh this, what will happen is eventually I think Amazon figures out that things are busted too. But let's see what happens here. So now if I do kube control describe. Now this is not Cockroach's problem. So what we're having here is that so it pulled it, created it, and then it failed. And it's not clear why it failed. So kube control log, oh, not that. Kube control log. Does that work? and then so the init container is failing. And so this is a trick also, is that if you want to get the logs for the init container, you have to specify the name of the init container directly. So the name of that init container is init certs. So if we do init certs, failed to write files, could not create symlink from the secrets to, oh, so this is interesting, is that because this thing was getting restarted in some way. All right, so this is probably a bug, Alex. I don't know if you're taking notes. Is that the symlink from the certificates into the service account thing already was created for some reason. And so that should probably be a no-op. And so I believe if I like kubecontrol SSH exec, let's see. Oh, I have to do the, so yeah, so I don't know if I can actually clean this up, because it's kind of busted at this point. And so this was the init container. What was the init container called? Yeah, so Alex says, not good. I broke it. I knew I was going to break it, Alex. I was going to find a way. Yeah, so I think what happened is that something got mixed up, and the thing that's trying to initialize certs like didn't find things as pristine as it thought it would, and so now the init container can't complete. There's no reason why it shouldn't be able to. I think there's just a little bit of a bug there. So so this is not the end of the world. I think if we go through now, if we wanted to say like, oh my God, the service is degraded, alarms are going off, what I would do at this point is I'd do kubecontrol, delete pod, and then CockroachDB2. Let's go ahead and delete that pod. That's going to terminate. And we might as well. So we get rid of that one too. Yeah, it's odd though, since the cert volume is an empty dir volume. So I'm not sure why that happened. It could be that it ran once and then it crashed for some reason, and then it ran again and it crashed for another reason. Or maybe like there's some sort of weird behavior going on there. That's not what I would have expected to have happen there. So I'm not sure what's going on there, Alex. Sorry. If you can track that down, we might have found a bug in Kubernetes itself. All right, so now this thing is doing the init thing again, and then the pod is initializing, and now our cluster is back up to full strength, so we're in good shape. So I'm not sure what happened in that particular case. Meanwhile, nodes, we have all full nodes, and then did 1, 2, 3, 4, 5. Yeah, and so Amazon recognized that that node died also. So I think we're in good shape. So Abraham says, is it mounted into containers? Well, the empty dir should be local to that pod. And so it should first get mounted into the init container, which is going to do all the sort of cert magic. And then it should get mounted into the main runtime container. And I think what Alex is saying, and I agree with, is that it's odd because how could that symlink say this thing's already there since it was an empty volume? And so either maybe the init container failed for some other reason, and then we restarted the init container. So that could be possible. Or, yeah, I don't know. That would be my guess, is that the init container failed, and so the init container got restarted multiple times. And so maybe, oh, you know what? Okay, here's what we're going to do. We're going to debug this a little bit. So if we do... we have logs, right, the init container. What we can see is that now oh no, I deleted the thing. Shoot. Because there's an option in kubecontrol logs, which is previous. And so that was probably the last run of the init container. Probably if we looked at previous, we'd actually see that there was a previous run of the init container that failed for some other reason. And that's probably the root thing, and then that caused the empty dir thing. But unfortunately, I lost that state, so we can't figure that out now. I don't know. So we'll have to try and repro that. All right, so that's all I had for today. I think this is a real, oh, we were going to tear it down. Let's tear it down. Let's go ahead and, so you can scale the cluster up and down and like magic things happen. I don't think we're going to have time to do that. And then we're going to stop the cluster. So we can do it like this, where we're deleting all the stuff like that. But what I'm going to do is I'm going to do a cube, or I'm going to do like the, I'm going to do cube control, delete -f, and then we're going to delete the job because why not? Okay, so now if you play with this with a toy cluster, make sure that you tear things down cleanly, because if you don't, then those volumes will get left along. So if I were going to go and actually delete the CloudFormation stack for the cluster, it doesn't actually know that, hey, these volumes were logically part of that cluster, and so that'll orphan those volumes. Let's see, well, that's actually a nice thing about Azure, is Azure has this idea of sort of like resource groups. And so the resource groups in Azure are in some ways a little bit like projects in GCE, but essentially you can create a resource group for your cluster, and then that includes all the things that that cluster creates also. So it's a flexible way to sort of group things and then tear them all down. So Alex says, I think the pod got rescheduled to the node that it crashed originally. Not sure if that means anything. It could be, but that thing we restart, I don't know. Alex asked me, because even though it had the same name, it's a different instance of the pod, and so it shouldn't reuse things from the previous run of that thing. So I'm not sure what happened there. All right, so now what's happening is that we see that because of the, when you scale down a stateful set, it scales down in a very, very deliberate way also. And so what we're seeing is it's taking its time to actually terminate each one of these things, wait for it to do a clean termination, and then bring the stateful set down. Now there's options with stateful set that you can say, you know what, don't worry about the ordering, just blast everything up and down, but we're not using those. But we can see that our PVCs are still here. And we're gonna, so let's go through and we're gonna do, and for those that were asking earlier about PVCs, what we can see here is that the reclaim policy on the PV is delete, which says that, hey, when this PVC gets deleted, then I want to delete the PV, right? But there's no sort of reclaim policy on the stateful set that says, hey, when the stateful set gets deleted or shrunk, go ahead and delete the buddy PVC. So that stuff's not usable. And then Lamatti says, is there a way to get the last access and creation time of a PV? Oh, and then our forwarder is now like, hey, stuff's busted. Okay. So yeah, so now we're done. So I don't know, Lamatti. Let's look. So if we look at the PV, cube control describe, what we can see is that we got some metadata about it. Read only, partition, there's events and stuff. It may show up in the event, the last access time, but it doesn't look like it. Status bound, so it's bound to a PVC, and bound by controller, provisioned. I don't see anything that's like last access time on the PV, but what if we actually look at the PVC itself? That actually has, when it was provisioned, annotations, bound, but it's not in use. Oh, we were going to check to see what does it look like when it's in use. I don't see that. So I don't know if there's a way. So Hans says there are max unavailable in the deployment also. Yeah, so the max unavailable, I believe, Hans, is for when you're doing an upgrade of a stateful set. Or in the deployment. Yeah, in the deployment. Same thing. Yeah. Okay, so now we have to go through and let's delete those PVCs. Cube control, delete, PVC, all. That deleted those, and then that'll go ahead and delete the EBS volumes that are behind the scenes also. David, thank you for setting that fix for the 302s. Because whenever, I would only do the, I mean, like maybe if you're hitting it and it's not coming from localhost, not, you know, if the host header is not localhost, then do a 301. But if you're doing localhost, it's kind of bad form to do a 302 on localhost because you reuse that stuff all over the place. So yeah, so now we're cleaned up, I think. Yeah, so I am really impressed. This is some really slick stuff. Obviously, we just scratched the surface in terms of using CockroachDB. And I think over time, what we're going to see is that, especially with things like, including the meta controller, but also like the Jetstack Navigator stuff, we're going to see more and more opportunities for people to build first-class sort of, stateful set management on top of Kubernetes. And so I think the end state here is that we get things that feel a lot like, say, something like Amazon RDS, but actually have sort of the extensibility and the portability of running stuff on top of Kubernetes. And I think that's a really powerful combination. I think, and I think that's going to only get better as we see more and more systems like CockroachDB that are built from the ground up to take advantage of the dynamic nature of systems like Kubernetes. There was like 2 namespace default in the YAML. What did they mean? Where did you see that, Hans? Let's see. Oh, those were in the role bindings. Yeah, in the cluster role bindings. Because whenever you specify a service account, you have to specify the namespace for the service account. You can't leave that blank. Whereas if you leave the namespace blank in the metadata for everything else, then kubecontrol sort of stamps the current service account on that. But that doesn't work when you're talking about the subject for a role binding or a cluster role binder. So Lamati says, on the point of storage, do you happen to know if anyone is using Gluster, Ceph, or Heptio in production? I know a lot of the OpenShift deployments use Ceph. I don't have any experience with it. I know that, people both swear by and swear at it. I think the interesting sort of, upstart in this world is, Hans says, so it was locked to default there. It wouldn't work if you, yeah, it's an easy thing to modify. I think it's a reason to do some sort of level of templating on this stuff, whether it be Helm or something like KSonnet. So it's a good point, though, that this would not apply out of the box to a different namespace. So the upstart in the storage world is Rook, and so Rook is really interested because it uses a lot of the sort of data plane parts of Ceph, but it's more like Cockroach in terms of the management stuff is built to be run dynamically in a system like Kubernetes. I think the larger issue is that there's the whole idea that you're going to be reusing the same infrastructure for both storage with like block devices over the network, and you're going to be using it for your workloads. That whole scheme is what people called hyper-converged storage, because you're running both your storage, your SAN, and your compute all on the same system. That is some really interesting stuff, but I think a lot of people underestimate how that type of system acts at load. The reason being is that it's very easy to start saturating your network when you're running both workloads and storage over it. And when you end up with a saturated network, distributed systems like Kubernetes have some really wacky failure modes, because what happens is that, hey, I can't go ahead and talk to this node. I can't do a health check to the kubelet, so therefore the kubelet's down. Let me start re-replicating everything, and you end up in a cascading failure situation. And so the advice that I give folks is that I wouldn't even touch any sort of hyper-converged stuff where you're going over the same network for both storage and compute, unless you actually have a really strong, QoS, quality of service mechanism on top of it, so that you can make sure that your control plane traffic for things like the kubelet gets priority over any sort of data plane traffic, whether it be storage or other workloads. You're just much less likely to saturate your network with pure workloads versus, once you add storage onto the same network, things start to get dangerous. All right. So that's all I got for today. Thank you, everybody, for joining me. Hopefully you learned a little bit. I definitely did. This is a really interesting and exciting system. I'm glad to see that Cockroach is embracing, CockroachDB is embracing Kubernetes. There's a lot of good work being done there. I think it's going to get even better as we start seeing the local volume support happen. Because you won't be doing that double replication. That'll probably improve performance in these worlds quite a bit. All right, so tune in next week. I have no idea what I'm going to cover, but we'll do something fun. And yeah, and if you have any comments on the video, leave them in the YouTube comments. Give it a like or a subscribe, or reach out to me on Twitter if you have other stuff. Yeah, so echo C to proc sysq request trigger and then watch the world burn. That's exactly what we're doing. All right, I'll talk to you all later.